basic machine programming for a face and turn part is really quite simple on a Mazak. So generally you'll start with left soft key and you'll hit your program button here. Now you'll want to edit a work number. You pull it up a work number. And if you don't already have a work number, it's okay, because if you just put in whatever work number that is, oops, 235, that's fine. Generally, you can't have more than 4 digits in a row without a dash. On the lathes. The mills are different. But we'll do that, hit enter. It will ask you to either have a new program menu. You'll have Mazak program, or you can do a general G-code program, which isn't terribly difficult. If you know G-code, it's really quite simple. Mazak is obviously something that not everyone knows. Hit your Mazak, and the first thing I'll ask you is what your material is. This does not matter if you care about your feeds and speeds, because all this is just conducting feeds and speeds that are in its computer to automatically input if you don't know what you want to do. So we'll just do carbon steel, because I don't care. It'll ask you next, what is the max outer diameter of your workpiece, OD max. So 2.5 inches is what I'm going to input here. ID. You don't have to have anything here if you're not doing an ID. So an ID minimum, you don't even have to put anything there. Length. I want a 5-inch length. Work face. Now this is however much you're facing off of the part. And generally that facing off of the part will be your Z0. So you'll put in, I want to take off 50 thou off of this side of the part. So I'll put in 0.05. RPMs, this will max out, this will tells you exactly how much RPM that the machine is going to have just in the program itself. This is for the whole program. This is not for anything else. If you want to max out your RPM or limit it in different parts of the program, you have to use M codes.
This does not apply to live tooling. Live tooling is in tool data.
The live tooling, yes, exactly. The live tooling max RPM is in its tool data. This one I'll do 1500, even though it's kind of slow. So when you're facing, it will only go down to 1500. So its surface foot per minute will actually start getting smaller. As it goes down, that 1500 it's going to max out. So our first unit is going to be turning, because we want to face the part. So we're going to hit turning. There are 2 different ways you can face a part from here. Actually, there's several ways, but I'm going to do the simplest one for this example. I'll do a bar face. Cutting point X tells the machine exactly where it wants to start the cutting point. If you go 2 inches, it's going to start cutting at 2 inches. But our max OD for our part is 2.5. We cannot go higher than 2.5 or else it will alarm out. It needs to know where to start. We're going to go 2.5 inches. Our cutting point Z will be 0 because that is where I'm going to have it set up. Our finish allowance in X is going to be 0.03. It doesn't have to be, and it really doesn't matter on a facing pass. What does matter on a facing pass is your finish in Z, because it's going this way. I'll put in 0.003, even though that also doesn't necessarily matter. Now, if you want to do 2 passes, if you want a rough pass and a finish pass, even though you have 50 thou, it doesn't matter. If you have a rough pass and a finish pass, you can have it come in, rough it out, and leave 3 thou in Z to finish it with. But I don't want to do that. I want to make 1 single pass for this particular use. So I will go over here, right soft key, and with my cursor on the first side general, I'll hit erase, and it will highlight the first part. So it'll have rough and finish. So I'm just going to have a finish pass. If you have a rough tool, it will run the rough part of the program. If you have a finish tool, it'll only run the finished part of the program. Now here, we will... Most people don't like using these, but you can if you want. It is useful, especially if you're doing multiple facing passes. This will leave a finished stock, finish allowance X. This is basically leaving stock in X and Z for the tool that will come in front of it or after it to take off more material, if you so wish. However, I don't want it to do that. I want to be one pass and I want to be done with it. So I'm going to cut at my cutting surface speed, which is probably already going to max it out at 2.5 inches. So I'll just set 800 surface foot. Feed rate. Your feed rate will be 0.08. Here, you'll have M codes. If you want to put an M8 in here for your coolant, you can have that here. You can have an M0 for a program stop. You can have an M1 for an optional stop. You can have a different M code for whatever else you would desire. So now, we add coolant to it because we want to keep it full as it does this big pass, which is, it's not a big pass. No one cares. So now that we're done with this particular line, we have now described the basic shape of the part, its cutting points, where it's going to start cutting in X and Z, or Z and X, and then we're going to describe what tool it is. It is a finish tool, so it's going to run the finished part of the program. It is a tool description of general edge. The tool number is number 10 on the turret. Now that we're finished with all of that, we can arrow down 1. And it will ask us pattern of figure. Pattern of figure designates, do I want to cut a line? Do I want to cut a taper? Do I want to cut a convex shape? A concave shape? Or, I don't remember what that one is. I did learn it at one point, but I never use it, so I don't remember. In this particular case, I will want to use line, because I want to cut a straight line down in X to X0. Start corner. When you do a start corner on a Mazak, it will almost always give you a 45-degree chamfer. That 45 degree is because generally, if you're going to make a corner break on anything, any print in the world almost always has a 45-degree chamfer. It's extremely simple. It's something that you're going to run into all the time. So it will always be a 45-degree start corner if you put one in. Now, if you want to make a radius, a round radius, you'll hit corner R right there. And if I want to make that radius, say, 150 thou radius from the top of the part to the front of the part, I can point in 0.15. So that'll be a general toolpath. But if I want to make it a corner, I just arrow back over here. I'll put in 0.03. That is a 30 thou, 45-degree corner break. It will always be 45 degrees unless your tooling is not described properly.
And that 30 thou is measured in linear Z, linear X.
Yep.
It is not 30 thou across the length of the angle.
Yeah. So, now that you'll also notice there's a diamond in X and Z for its start points, because it already gets our start points from our cutting points, X and Z. So it'll only ask us for our final point X. So our final point X is going to be X0 to face off the part all the way. If you don't want to go there, if you're facing off tube stock, you can face the ½ inch. So you can face down to a ½ inch. Or if you're running a big drill in there, you can face down to whatever this, like 100 thou below the drill diameter. So in this case, I want to do 0. Finish point, Z. 0, again. That's an extremely simple way to start programming. If I want to do a final corner, which you can't necessarily do on a face, it doesn't make sense. Why would I do a corner here or here in a face?
I had to think about that. Like, why would you
I would write a separate program to come in with a tool that's faced in Z to come and cut a corner or a radius in the face of the part. Which you
And
can't do
an
on this.
undercutting tool.
Yeah, an undercutting tool of any variety or anything else. So you don't have to do anything. Now, finish, surface finish feed rate menu. This is another auto setting based off of what your material is in its computer. This is preset things and whatever you told it that your tool is. Another finish sort of deal. So it'll go, you can either do roughness. So 1 is roughest, 9 is nicest and smoothest. This is nice for mills because it does actually work on mills. It doesn't always work on lathes. It's kind of weird, but I don't want to do that. Now, it says feed rate 5.9 here. If you want to override that feed rate for any particular reason, you can always hit feed rate per revolution. And I just want to make it 8 thou rev. Very conservative speeds. 8 thou rev will override what the feed rate is set here. This will always override it. So from this point, I'll hit shape end down here. This will end this. This is one block. This will come in, come down to 2.5, cut the chamfer, and face down to X0 in its Z0 position. So now I want to turn a ½ inch off of this part. But I can't turn a ½ inch all in one shot. They might shoot the part out of the lathe. Well, maybe this lathe, but maybe not another lathe. So I will hit turning. Again, just like we did before. Bar out. Cutting point X, just as before, 2.5. It has to know where our material is, or else it's going to cut air or it's going to slam into it. You have to give it what it is. Else it will alarm out.
This has fucked me up for years. You're telling it where the material is. You're not telling it its exact starting point. You're telling it where to expect material. Fuck me up further.
So if your material is bigger than this, it will rapid, say if you're 5 thou bigger than this, it will rapid 5 thou, maybe a little bit closer, but a little less close because there are buffers and you set your buffers and your ZPC information in the program. However, cutting point Z will be 0 because Z is 0 is our phase. 0. Finish allowance. I want to put 30 thou finish so I can have a nice finish on this part. Finish allowance in Z, I don't want any. Actually, I do want a little bit because when we make that shoulder of our turn, we're going to be leaving a step from our rougher, and we want to take that out. So I want to put 0.005, 5 thou.
I forgot about that.
So now it will give you rough, finish, general out, and then it will give you your tool numbers. If you have tools that are suitable for this sort of thing, it will already tell you, it'll automatically set them from your tool data. Pattern 0 and 1 are generally almost what you're going to use all the time. 0 will come up to that shoulder and then it will turn up. 1 will come up to the shoulder and then wrap it back to the front of the part and keep turning.
The difference is the shape imparted on the part. Tool comes in, goes straight up, makes a straight 90-degree corner. If you have a D&MD with a 55-degree corner, it's going to leave that 55-degree corner.
Yeah, it's going to leave a 55-degree sort of relief up in here on your shoulder, and then you're going to have more material taking out than your finish point in your Z for your finish allowance, which is kind of annoying and leads to quite a bit of chatter if you don't know that's what's going on.
Or just break the whole fucking tool.
It'll straight break the tool too. The machine doesn't care, you have to remember that. 0 is what we're going to use for this particular application. So I don't have a print here, but basically we're going to have a part that is going to be turned down to 2 inches. It'll be turned 3 inches back, and then it will have a shoulder that goes up to its 2.5-inch base diameter. And on the top of that shoulder, there's going to be a 45-degree chamfer. There's going to be another 45-degree chamfer here. Compound angles we'll get into later. Depth. This will set the max depth of cut for your tool. Woo. Max depth of cut for our tool here will be 150 thou, so 0.15. Cutting speed. You can always auto set this, but I don't like to because sometimes this thing is wrong. In fact, it's almost always wrong. Do it yourself, learn it yourself. So in this case, I'll do 495 surface foot. Our feed rate per rev. We're going to be roughing at quite the speed, so I'm going to be 0.015. So we'll take a 150 thou depth of cut, and this is depth of cut radially. This is not depth of cut on the diameter. The diameter will change by 300 thou, not 150. This is a radial depth of cut. It'll almost always be a radial depth of cut, and that counts for mils too. Again, we're going to find our M codes. And if you don't know what your M codes are, you can always go, and there are tons and tons of M code menus in this machine there for you to find. You just follow this arrow around. For this time, we'll just use M8 for our coolant. Now, we have the same tool. We're using the same tool to finish with that we're roughing with because we really don't care. Same sort of deal. We're not going to have any finish allowance in X for our finish tool because we want this to be two sides. If you make this 30 thou, it'll be 30 thou above what you tell it to later. It is going to rough it 30 thou above where you want it to be, and then it will do its finish pass at what you say it's supposed to be when we get down here.
If you rough it down here to 2 inches and you leave 30 thou, this will be 2 inch 30 thou. The finish is going to take it to 2 inches.
Now, if you say you want 2 inches, so if you leave a 15 in here and X, it'll be 2 inches. It'll cut only 15 thou and at 2 inches 30 thou left from the rougher. So it'll leave 2 inches 15.
That's how a lot of oversized parts have been made.
Yeah.
I don't know.
And the same thing for Z. It will leave material from the finish pass. So if you want to make multiple finish passes, this is nice because you can just copy this dimension, and you can copy your dimensions that we're going to write out next to it, and you can make a second or third or fourth finish pass if you would really desire to do that, even though I don't necessarily know why you'd want to. So I'm just going to hit input and keep it at 0. And now it'll still ask me what my surface speed is. I'll give it a good 600 because I don't care what it looks like. I'll do the same thing. I'll do a 0.01 feed rate and an M8 so it has nice good coolant on it. Even though I don't care what it looks like, I don't want to burn my hand pulling the damn thing out. So our first pattern will ask us, do you want a line or taper just like we did before up here? In this case, I want to have a taper because if there's taper in the machine, if this machine's been cutting for a while, and it's old, it'll have maybe 1 or 2 thou taper this way or that as it goes down the line in X and Z.
Or if it has brand new ways.
Or it has brand new ways, either way. This is, you can use a taper line to accurately identify where you want to go. We will be using tapers later when we do compound angles to teach more interesting things. Now I want to give it a start corner, not a radius, a corner. I want a nice 45 degree chamfer, and it's going to do that automatically. So I want to give it a 0.05 linear chamfer, 45 degrees. Now my start point in X for, you don't have to care about what material is on here because you're actually basically drawing what your print tells you it should be. So my start point in X for my diameter, my final diameter is going to be 2 inches. My finish point for my start point in Z is going to be 0 because that's the face. Right? My finish point in X is going to be, say, 2.001. Say I have 1 thou taper and I don't want it in there, and it's tapering down. Now I can always make it go up 1 thou, and it will level it out across these 3 inches. Oops. Because I wrote 3 there. 2.001. My final point in Z is going to be 3 inches. Final corner can be used here, but I prefer not to because it's much less predictable. So now I'll give it roughness, feed rate, or rev. I still want to give it 0.01, so I'll give it 0.01. My feed rate or rev, and that'll be my override. Now, pattern of figure. I just made my diameter as 2 inches, but I still want a chamfer at the top of my 2.5 inch. So I'm going to do that now. And this is where we're going to be a little bit more interesting. So taper, again, taper. Now this is where it's going to start changing. We're not going to use a start corner or a corner radius. My start point in X, I'm going to use interpolate. That's what that stands for, interpolate. And I'll use a question mark for interpolate. Start point in Z, 3 inches. Finish point in X, 2.5, because I want to have a chamfer at the top of my shoulder. 2.5, 2.5. Finish point in Z, I want to have a 30, I want to have another 50 thou corner. So I'm going to go 3 inches plus 0.05. So 3.05. I'm going to skip the final corner because this is my final corner. I'm writing it in so I can more accurately control. Final corner will always be whatever you say it is. Will always be a 45, or sometimes it can be a radius in here. Now, if you want a 30-degree chamfer up here and not a 45, you want it to be 30 degrees instead, you'll come over here, and it'll say taper angle, 30 degrees. Now all I do is I right soft key, and I hit this button that says calculate. And this will interpolate my start point in X to my finish point in X, from my start point in Z to my finish point in Z, and it'll give it a 30-degree chamfer. So I'll hit calculate. It'll be 2.442 is my start point in X. So it'll come up, turn, it'll come up to the nearest point in X. And that's how that works. So it'll always go from a diameter in a straight line to its next nearest point in X, which is going to be 2.442, and then it will start cutting again.
And this will be feeding, this will not be wrapping.
This will be feeding the whole way. Now we're going to hit shape end, because I don't care anymore. And I want to end the program, because I am done with this damn thing. So continue. I don't want to continue. I don't want to go to another program. I want it to just be this program. Number. Do I want to give it a parts counter? Sure. That way I can keep track of how many of these stupid things I'm making. Return. You can always turn it to its tool change position, which is going to be a safe position. It automatically calculates. It's called TPC. Automatically calculates where is a safe position according to its tool data and where its Z position is in the machine. So, tool change position there. Work number. Next workpiece number. So if you're making a flip, I'm not doing that. So I'm not going to fill it out. And that's the end of my program. So now I will give
Shape check?
Yep, shape check.
Now.
There you go.
Okay.
Shape check. Now do shape continue. So again, it'll face it. It'll leave that gigantic chamfer because you put a 300 thou chamfer in there when I was looking. I knew you did that. But this will also be a good thing to see. Scale change. We're going to bring our thing up.
One button at a time.
One tick at a time. So remember, I said it's always going to be a 45, right? So I have a 45-degree chamfer at 50 thou, and then he wrote in a 300 thou chamfer as well. They are still both 45s. The start corner will always be a 45. But if I go back here, just like I did just now, I do shape continue, it'll show you. This is how it's going to write. It's going to face the part down to its X point, the center line. It'll come up. It'll start roughing 150 thou at a time. And then it'll leave that chamfer. And then it will turn. And then it will come up and then break that corner up there.
Everything you see in purple is the finished part.
Yes.
Except this. Everything in purple is finished part.
Now, we can actually watch it do this if we want to. We can go to position, go back to our position page, program. Now we can hit something called Toolpath. This is the machine getting all the tool data together and figuring out what's there and what's not. So if you don't have a tool here if you have a tool like tool number 10, which I don't want to use, or tool 10 doesn't exist in my turret, then it will go, hey, what the heck's going on? I don't have this tool. Why are you making me do this? So I don't want to use tool 10. I'm going to have to edit this. I want to use tool number 7, just like I'm using for everything else. So I'm going to use tool number 7. But now you'll notice there is a discrepancy. I have general edge. I have general out. General edge and general out are two different things in tool data. Here, I'm just going to go general out. I'm going to switch that so that it's the same thing, and it will be aligned in my tool data. Tool data, number 7, general out. And it's a right-handed tool. So I'm going to go back to my program. I'm going to hit Toolpath. Now that everything is there and there should be no discrepancies, I'll hit Part Shape right here. And then I'll hit Path Continue for a path step. Path Continue will just run the whole thing and you'll never see what's going on. So now it'll start at 2.5 inches. The green line is always the rough stop. The purple line is the finished part. So it'll start at 2.5 inches. It'll come over here like it is, and then it will start turning that 300-pound ungodly chamfer, which it's never going to do without breaking an insert. I mean, it might do it a few times, but it's not going to do it consistently or safely.
Gotta be optimistic.
I'm not optimistic. So now I'll get past step again, and you'll notice it stops for a second above the part, and then it brings it down above the part again. We'll do this again. Path erase. We'll go back to it. Path step. Again, there's this that goes down to the part, and then it begins its cut. That is part of the TPC. It automatically, in its parameters, has something that tells it I have a buffer of X and Z. That way I don't hit the thing in case it's, rough, like really rough stock and not a nice, like, turn and polish part, and it's doing this as it's cutting. That way I can avoid that and it doesn't chip the hell out of your tool. Now that it's cut my chamfer, I can pass step it again, and it will come down to X0.
And you'll notice it is in front of that home icon. It is in front of that.
Yeah.
It's not at Z0.
Because I left 3,000 there, didn't I? So it'll come up, it'll bring the tool out, away from the part, it'll wrap it up. I'll give you a part shape, that way you can see. It'll wrap it up and it'll do its first turn. Its first turn here is going to be 150 thou depth of cut radially, not on diameter. So whatever its diameter at that point is going to be this minus 300 thou. So 2.2 inches.
Just imagine that same line down here.
Yep. So path step, it'll wrap it up. Do this again. It'll wrap it up in a straight line. Straight line, it'll feed up in a straight line. It'll start to break that corner, and then it will go back and then do its final rough turn. When it does that rough turn, it leaves that 30 thou stock that we talked about earlier. That way we can finish our turn. It'll go up and X. It'll then miss everything. It'll actually interpolate its first rough pass to its second rough pass. That way there's a nice straight line. Then it will wrap it back down. It'll wrap it down to its start X position, which is what we were looking at earlier for our chamfer. It'll cut that chamfer, wrap it up, or it'll turn all the way back at its speed rate, turn up. It'll turn up the rest of that Z that we had, that Z tolerance that we had there, and then it will finish our chamfer. And it will wrap it home. And that will be the end of our program. And it will also give you a rough toolpath time. So, very simple part, very simple program, but it's a lot easier than writing G code. Sometimes.